Hello everyone, welcome to Hydra Book Reading Club, video 11, continuation from the last one, the topic on colors. And in this video, I'm going to combine the color we explored a bit in the last one and the modulation, how we remap colors and do some interesting color experiments. Hopefully that's helpful. And just a small thing, but if we go to the Hydra book page, so I hope you're already familiar with this website, Hydra book, and it's an online book if you don't know, book quote unquote, but I wrote it with code snippets, text to explain how Hydra works and how we can go deeper into different functions, not just the combining functions, but understand how it works, how we can make new combination, not just naively or blindly experimenting, which is also important. So I think it goes hand in hand to understand the logic and also trying, experimenting. And this Hydra book I migrated from glitch.com to GitHub pages. The domain looks almost the same, there's redirect and everything, so you will not notice any difference, but just so you know that glitch.com is retiring. I think it's already retired when I published this video, but still the website works. So great. You will not notice anything, but I did some work. Anyways, so let's go to the topic, and I'm gonna make myself smaller, shrunk. And we talked a bit about colors last time, and we didn't really follow the Hydra book, which is not really. I mean, that's the point of the book, the video, that I will add more content to it, and then maybe after filming this tutorial series, I might rework on Hydra book. But the first experiment, just to kind of give fresh insights to Hydra book, because this I wrote maybe like 4 or 5 years ago, and color mapping. This is like strategy I use a lot in my Hydra coding, and I already talked about it in the modulation. I think it's a video 6 of the Hydra book tutorial series, and let's just do a recap of that. So I will just clean up the editor, starting fresh, and basically the kind of color source is this OSC that I always use. This has like, as I talked in the last video, it's not a rainbow, but it looks like kind of rainbow, and it's really nice to use this as a starting point. And basically, I did modulate. I'll do with Voronoi today, just because I feel like that, and I will just make it paused, no movement here. And if I just do this, you start to see a little bit of Voronoi in here. It's very subtle, more like a kind of holographic kind of effect. And to enhance it, I will make modulation from default 0.1 to 1, just like, this is like really drastic effect of modulate, and you probably don't want it most of the time. But in color remapping, I always use 1 instead of 0.1, because that makes this like really, like almost color remapping is happening here, although technically not really like a true color remapping, because on the left side, on the right side, there is still like color, like a tendency of, like in this case, on the left, it's more like, well, on the left is this side for you. It's mirrored for me, but anyways, on the left you see this like orangey color, on the right you see more like bluish color. So if you want to like make a true color remapping, you want to do like sub gradient, basically subtract the gradient, which will cancel out what's happening with modulation, and this kind of makes a true effect of color remapping. Well, like when I say effect, it's like visual effect. And what's interesting here is that now it's like a lookup table that, if you see like Voronoi, so basically it's the same shape as like the contour, or like the shape itself is same as this, right? And now what is happening in the remapping is like, let's focus on this black part. There's like two or like a few black parts that becomes blue. I mean, that's kind of like, I didn't really calculate it, but actually I can calculate it or eye it. If you see, this is like a lookup table. So what happens is that the black color in Voronoi will become something like the color on the left, which is this light blue. So if you see it, these, I remember like this part was black and it becomes like light blue. And what happens to, let's say, more like a grayish part, like this thingy in the middle, like just above the black part, which becomes more like orangey, yellow orangey color, because it's something in the middle of this, let's say like a lookup table, and something close to white, let's say like this part, like between these black ones, it's actually like kind of gradient of like purple to red, because that's more on the right end of this lookup table. But also like this one almost like wraps around, so actually the black ones and white ones can have very similar color. But basically this is like what's happening. The black one goes to, look up the color from the left, and gray ones in the middle, like between white and black, will be something in the center, like orangey, yellow color, and when it goes more like white, then it becomes more like blue and kind of wraps again. So that's the kind of when I say color remapping, and that's such interesting visual effect, because you cannot really achieve the same thing with like color function. This is another trick to make, like add color to it, but this is still like kind of gradient from red to, in this case, red to cyan. And the problem with this is that the color in between, like this grayish ones in the original Voronoi, like this one, this looks a little bit, it doesn't look really interesting in this example, because it's something like mixed of red and cyan, which ends up something like this kind of red tinted gray. And compared to this, what we did with this is like, there is no gray, because if you look at the OSC, the lookup table, or this palette, there is no gray in this spectrum. So it's always like sampling from like blue to light green to yellow to orange. So it's like, again, it's not rainbow, but it's almost like a rainbow that you're like sampling, and the Voronoi becomes a rainbow. Great. And actually, like most of the time I just like finish here, like this is great, so I'll add like layers, masking, feedback, and work with this as a kind of material. But if you want to, and also I think I should work more with the colors, and if you want to like dive deeper into like colors with this like specific technique, which is possible, like in the last video I talked about it actually, that for example, if you look into this one, you can like, for example, scale it, and then suddenly you have this like really kind of stretched out OSC that has its gradient from, let's say, like light green to yellow, orange to like almost like purple. And this is great, because then I can use this as a new lookup table and use this for remapping, and you end up with Voronoi with these colors that we just created. And if I'm not happy with this specific color, I can also do like scroll X and 0.1, for example. Okay, this has a little bit more like purple, like bluish color, maybe a little bit further out there. Maybe I will work a little bit like more like this here, maybe, or even this one. Or it's like, fine-tuning that you can probably have fun with, like tuning these colors with the scroll X and scale. Also, it's important that you do scroll X first, because if you do scale first, then problem with the scroll X is that it's going to wrap around, So if you stretch it out, it will cut out what is stretched out and it will wrap around. So you see this kind of weird scene, which can be actually also interesting if you want to like use it. There's nothing that stops you from using this. Like now we see these like circles, which I don't know if it's ideal for your case, but it's up to you. But in my case, let's say I'm not that interested in this result. So let's say I do the scroll X first and scale it into that part. And okay, I want kind of like orange to blue, like it's almost like a kind of chromatic kind of color shift, which is super interesting. So let's use this one and put it in here. So now I have Voronoi with this color palette, and I'll just delete this one. Yeah, and again, you know, there's nothing that stops me from adding this movement, and it still works fine. There's one note that now I deliberately started with Voronoi because Voronoi is returning color from 0 to 1, like 0 meaning black, 1 is white. So it's kind of straightforward to work with Voronoi in this case. But if you want to work with noise, which is also like a popular source function in this case, it will end up with something a little bit different. Let's do this here. It feels a little bit kind of brighter, like, or like more like yellowish or even like green, which didn't appear in this one. So why is this happening? Is because noise is not, I think I iterated this in the videos, but it's not returning from 0 to 1, but it's returning from -1 to 1. And does that make difference? I mean, in this case, it's quite crucial. You don't really notice this most of the time, but if you just like run noise.out, it's actually quite dark. It's not actually, it's very different from like Voronoi in this case. Voronoi is like more grayish because the thing with Voronoi is, again, it's returning from 0 to 1, and when it's like on the screen, all the color, well, spectrum of like gray spectrum from, you know, black to white is rendered like this, like properly. But if you take noise, it's actually like exceeding the black, so it's like there's like a blacker black on the screen, but whatever is below 0, like negative number, like negative color, that's rendered as black, same as 0. So it's almost like, you know, luma or like a thresholding. So if you do, well, doesn't, of course doesn't do anything, but well, this does. But what I'm saying is that, for example, like if you thresh at 0.5, which in the case of Voronoi, you say, let's say like half of the screen almost is still like painted white because it's kind of distributed almost like evenly between 0 and 1. So if you take middle point 0.5, well, I'm kind of simplifying this, but if you take the middle point 0.5, then you can see that black part and white part, like histogram, if you work with like image editing software, histogram wise, like distribution of like black and white is kind of the same. But with noise, because it's more like distributed more on the, well, the middle point is 0 instead of like 0.5. So if you take thresh 0.5, it's actually much darker and you see more like white as like these dots, which is also interesting. But in this case, like if you do thresh 0, then you can see that the distribution of black part and white part, or the area of black part and white part, is kind of equal almost. So what I want to say, that was a kind of, I don't know if this explanation was helpful for anyone, but what I want to say here is that with noise, it takes color from outside the spectrum I wanted to create. Well, I created. There are different ways to kind of go around it. One is, what if I want to make like a noise, like a new noise function that returns from 0 to 1 instead of -1 to 1? And that's possible. You just have to do some math. So it's basically like, you know, sometimes in P5.js you want to remap sine wave, which is like -1 to 1, which is similar to noise, to 0 to 1 range, for example. And the way it works is that you want to shrink it, to compress the amplitude by 0.5, and you need a bias to add 0.5. So basically what I want to do is something like this, which of course it doesn't work this way, but I want something like this. Then the range of noise will be from 0 to 1 instead of -1 to 1. Like if you do like sine, I don't know, like this is like what I want. But we can't do this way in Hydra, as we know. Hopefully you know this at this point. But instead we can recreate this effect. It's a little bit lengthy, but you can do like color. Basically color function is the multiplication, and I actually don't need all these 0.5, but let's keep it this way. And to add this is brightness 0.5. And if I use this, well, let's see how it looks. And now you can see that it's the noise, like this is the noise that you've never seen, maybe. That is more like grayish. It looks more like a cloud actually, which is kind of interesting. And noise function is often used for generating, like synthesizing like cloud kind of texture, by overlaying different, how to say, frequency of noise, which we can actually do, but this is color topic, so let's like keep it aside. And instead of this, I want to have this one here. Let's add new lines and let's run it. So now I successfully created this color remapping. So now this color like palette and this looks same. I mean, so noise is now sampling only from this range, not exceeding the range which is happening before. I think this is great. Another way to kind of go around it is basically we can like work on the range itself, but this will be a little bit more like mind bending, I don't know, because now if we adjust these parameters, I think we can recreate. So basically, like instead of like scaling 2.5, I will like amplify it to like scaling 5, but then scroll X has to be adjusted as well. Like now it's like more orangey, it's not the color we wanted. I don't know if it's like, I'm not doing the right math now. Oh no. So this is like kind of like ballpark, it's the same, but it's not as precise. So either way, like, so it's, again, it's not really precise, and you can do some calculation and define the right parameter for scroll X and scale to recreate the same effect without doing color and brightness. So either way, like, you know, if you feel like this is the way I want to work, first I create this exact color palette, or like I want this one, or it can be even, you know, further in, and the scroll X can be like minus as well, right? And this is like kind of more like a fresh, you know, I don't know if it's tropical color I want to use. And then if you're like really like stuck to this palette of color choice, then you probably want to use this noise, color, brightness, lengthy, expression, and finally, well, maybe this scale 3 is a little bit too narrow, so I'll make it 2.5, for example, and this is something I want to use. Or if you are like more like feeling like free to experiment, you know, starting with like noise and then, okay, this is a little bit too much. And I think this kind of weird wrapping is also happening, but actually this is kind of interesting. But if you're like, you know, feeling more free to experiment and just like changing these colors, I don't know what illegal character here is. That is also a way to work with colors. I mean, there's nothing wrong with like either way. And I don't know, for example, I like this, that's also fine. Just so you know that when you work just with noise without this lengthy color brightness thingy, then you might have this weird color, like weird edge, the color, which is actually like very similar to when you do like pixelate, right? Pixelate. This is something I already explored in the previous video, one of the previous videos. Like, if you, when I talk about color remapping, you can also do like pixelate, for example, to the color palette, right? So instead of this, I want the color palette to be pixelated. This itself is not, well, it can be very interesting and very abstract Hydra art, but also if you use this as a kind of palette to remap noise, you can have this like really interesting like kind of cartoonish effect. And you know, I pick 4, but it can be 5, or it can be even 2. This is more like thresholding. And now it's like really interesting because this is something like the kind of color experiment, color palette that you don't really do with Hydra often. It's more like kind of P5JS-ish, but also like it has this like noise that comes from Hydra, which I think is interesting. I will keep this here, and just in case I need it later. For example, I can also use Voronoi and see what's going to happen. In the case of Voronoi, I kind of neglected the third parameter, but third parameter makes a bit of like a gradient inside these cells of Voronoi. And if you don't like it, now I see these like circles here and there, which I don't really like in this particular one. So I just add 0 to the last parameter, then I'll make this kind of, I can make these cells really like having uniform, harsh color in each cell. But that's your preference. It can also be like very much enhanced, so it's more like kind of circles, like blobby things happening. But let's keep it to 0, and maybe the color palette wise, I will make it a little bit more like distinct colors. So I want this one. Yeah, so now I see that this Voronoi is colored in different ways, which is interesting. I think I did pixelate for just to be coherent with what's here. Okay, so I will keep this like this, maybe. I think I really like this result. It's really interesting. And this is like why I'm writing Hydra, well, I wrote Hydra book, because I really want to like see something that is not just like combining functions, but what if you start to really understand what modulate works, like how we can make color remapping and so on. And then if you like dive into like deeper and deeper, then you can start to create this kind of result that is like not Hydra-ish, but also actually this is like very Hydra code. Like I'm not adding in anything that's like P5JS or even like arrow function to it. It's like purely Hydra code, but it generates something that is like very much non-Hydra-like, which I really enjoy to do. So that's like my intervention to Hydra. And if you create something interesting, please post it in a comment down below, or you can share it with the group in like Facebook or Discord. I don't know if those, like Facebook is still alive, although Discord is, I know. Please share it with others and inspire each other. I think that's the beauty of open source and live coding community. Also, there's the Pasta gang or whatever, you know, people doing fun Hydra stuff or live coding stuff. So please share with others. And if you have comments, questions, please comment down below. And thank you for watching. If you like it, please hit the like button and subscribe if you haven't done it yet. And in the next video, I think I will talk, oops, this is my channel. So I think this is like kind of done. I'm gonna skip this part with the coolers. I mean, this was kind of also interesting, but it's a lot of like coding and I'm kind of overwhelmed by this. So maybe I will go to the next topic of layers, but this also, no, this is actually just a video tutorial link. So arithmetic, this actually like normalization, this is exactly what I talked about with noise. That is like noise is -1 to 1. So that's why like, yeah, I did it in a different way, but basically how to make normalized noise, that's exactly what I talked about. So I might talk about like blending, and or maybe I just skip this one because I think this is like I talked about it in intermediate tutorial. So I'll probably like experiment with like motions, and but this is also like same as like what I talked in modulation. But maybe I think there are some things that I haven't discovered in the last videos, like specifically about creating motions with modulate and compare it with arrow function. So stay tuned, and I'll see you in the next video. Bye.